Ladies and gentlemen, a reminder to our Climate Council designees, if you would, there's plenty of seating in the first 3 rows. And welcome to the North Carolina Climate Change Interagency Council. It's our 6th meeting. There are restrooms outside the hall, and special thanks to the museum for hosting this meeting today. We appreciate that. And it's, as always, my pleasure to present Ms. Sushma Mazemore.
Good afternoon, everyone. Welcome to our 6th meeting of the Interagency Climate Council. We're glad you're here. Today we have designed this special meeting for our designees of the North Carolina State Interagency Climate Council. The purpose of this today is to inform what our team of scientists are going to review regarding their key findings related to climate trends in North Carolina. Today, we're also going to talk about how the council members are working together to prepare the product for the Section 9 of the Executive Order 80, and that is the Climate Risk Assessment and Resiliency Plan. So that is what we're going to cover today. It's intended mainly for the council, but we've invited the public, local governments, as the information to be presented will be useful for us as state planners, local planners, business owners, decision makers, as we embark on how to integrate this information into our decision making. So with that, what I want to do is take the next few moments to introduce Jeremy Tarr from the governor's office. Jeremy has a few words to say, and then we're going to do an introductions to the council designees so that our scientists know who they're presenting some of their key findings to. So, Jeremy?
Thank you, Sushma. Good afternoon, everybody. I'm Jeremy Tarr from the North Carolina Governor's Office. I'm Governor Cooper's policy advisor on climate change and a number of other topics, as well as his designee to this council, the North Carolina Climate Change Interagency Council. Very looking forward to this meeting today, where we're going to hear from scientists who have been conducting a pretty important assessment of climate stressors for North Carolina. I think of this as we hear about or have read international scientific assessments of the impacts of climate change. There's a national climate assessment focused on the United States. What some of the scientists are working on is a similar thing, but downscaled for North Carolina. So glad you all are here to hear firsthand from the folks who have been working on this report. In particular, I want to thank some of the organizations and scientists that have been working diligently for many months on some of the analysis behind the highlights that you're going to hear about today. In particular, Dave Easterling from NOAA, Ken Kunkel from NCICS, as well as both of their teams. They're not one-person shows, but there's a team of folks that they're working with. In addition, I'd like to thank members of the Climate Change Science Panel, which is a group of scientists who have worked to also contribute to this analysis and are peer reviewing the analysis. In addition, I'd like to thank our state agencies who have really been working hard in coordination with these scientists to make sure the science that we're going to hear about and that will come out in a report later is really actionable, and also to start assessing what the impacts of climate change are for our state cabinet agencies and various sectors across the state. So with that, thank you again for being here. Really appreciate the work that everyone who's contributed to today has put in. I want to especially thank Secretary Regan and Sushma Mazemore for their really diligent work, not just with the Clean Energy Plan, the greenhouse gas inventory, and a number of other large lifts that they've really followed through on in the past year. A lot with stakeholder input from folks in this room, but also working on this resilience plan in parallel. So thank you to DEQ and leadership there for your hard work on this.
With that, if we could just have, I think most of our partners are in the front row. If we just start with Toby, just introduce yourself and what or agency and what your program office you're working on in Section 9.
Hi, Toby Benson. I'm with DEQ's Division of Energy Mineral Land Resources. Also work as the department's liaison with INCOR. So on top of that, I've got some RSF environmental preservation duties to work with our INCOR team. The groups I'm working with, on 3 chapters of the report. The one that's going most expressly for me right now is our chapter 5 with our different sectors. I'm working primarily with the water and land resources sector, but also assisting with the building, housing, and support services sector.
Hi, I'm Doug Holbrook. I'm with the Department of Public Safety. Our focus now is preparing sections that have mainly out of our Office of Recovery and Resiliency on hurricane and other storm and emergency response, and also operationally within our department, because we have such a large land mass within the state and large number of buildings that we have looking at our building, housing, but also operations for public safety and law enforcement.
Good afternoon. I'm Dan Money, Deputy Secretary for Health Services. I'm also the Executive Lead for Executive Order 80, work at the North Carolina Department of Health and Human Services. Joining me is Iris Cooper. She is the designee to the Interagency Climate Council. And also with Iris is Lauren Thee. Lauren is epidemiologist in the Division of Public Health, our lead author on our section of the climate change report.
Hello, I'm John Harden. I'm the Executive Director of the Office of Science, Technology, and Innovation in the North Carolina Department of Commerce. And I get to hand the microphone to my boss, George Sherrill, the Chief of Staff at the North Carolina Department of Commerce, and he's going to do all the talking.
I have a lot to say, but again, George Sherrill, and I'm the designee for Secretary Copeland at the Department of Commerce. We have Chapter 5 of the plan of the resiliency for this section. And the author of that is Will Best, and I'm going to let Will introduce himself.
Thank you, Will Best with the North Carolina Department of Commerce, and we've been working collaboratively on Chapter 5 for the risk assessment and resiliency for the agency.
Hello, my name is Heather Hildbrent with NCDOT, and
I'm Colin Miller, also with NCDOT in their Environmental Policy Unit. Heather and I are working on the transportation section of Chapter 5. We finished a section by completing the electric vehicle plan that we presented last October, so we're still working on that with one hand and doing the resilience plan with the other hand.
Hi, I'm Mark Edwards. I'm the Chief Deputy Secretary at the North Carolina Department of Administration. At DOA, we're still continuing to implement our plan to get more electric vehicles in the North Carolina motor fleet, while at the same time we're working on the resiliency with our state buildings.
Good afternoon. I'm Emily Roach. I'm the new Policy Director for the Department of Administration, replacing now Deputy Secretary Betty Morrow Taylor. So I'll be working with Mark and the team at DOA in increasing the education for the importance of the ZEB vehicles and carrying out the rest of our deliverables in the plan.
Hi, I'm Misty Buchanan with North Carolina's Natural Heritage Program, and I'm working on the risk assessment section for ecosystems, and I'm also working on the Natural and Working Lands plan.
Hello, I'm Reed Wilson. I'm Chief Deputy Secretary at the Department of Natural and Cultural Resources. I get to work with Misty. And the other parts of our department that are involved are state parks, the Clean Water Management Trust Fund, and the State Historic Preservation Office. All these are involved in different parts of this plan. Thanks.
Hi, so much for sneaking in late. I'm Marlena Byrne with the North Carolina Office of Recovery and Resiliency. I'm Deputy Chief Resilience Officer. and we're working very closely with DEQ kind of on all aspects of the plan.
Hi, I'm Amanda Martin. I'm also Deputy Chief Resilience Officer with the Office of Recovery and Resiliency and staff to the State Disaster Recovery Task Force, which is where, in our defense, we just came from a task force meeting of our housing subcommittee. So I think that's it. Is there anyone else?
Thank you, Amanda. Is there anybody else that we left out from introductions? Okay. We do know that there are 3 or other organizations, just for your information, that are involved in our response to Section 9. From DNCR, the Cultural Resources Group is very active in preparing their portion of the Risk Assessment and Resiliency Plan. We also have a team from the Military and Veterans Affairs that's working on their portion. And then, of course, our partners at Department of Agriculture. They have been very active and very responsive to doing the inward look at the agency's assets as well as services. And along with them, the Division of Forest Services, very active in preparing its content. So we are, as I'll explain later, at a stage where we've all done the education and an understanding, but really it all started with our conversations with Dr. Kunkel and Dr. Easterling. About a year ago, almost 9 months ago, we posed this question to them: how do we get started on this Section 9 of the executive order? And part of that required us to understand, well, what is the science telling us? What do we know and what don't we know? And our intuitions and our daily work allows us to do our own research and our own findings to get us started. And many of us have begun our work based on that research and that analysis. But in parallel to that, Dr. Kunkel and his team volunteered their own time and their busy schedules to support the state of North Carolina. And what they are producing for us is a completely independent product. It has not been filtered or evaluated by any of the state agencies. This is in service for the state as well as our governments at the local level and our planners and our communities and businesses. So with that, we're going to today spend most of the agenda on dedicating to their long effort and their teams numerous hundreds of hours that have gone into this process. And they'll be covering what they looked at and why and what the results are telling them. But following that, we will spend a few minutes talking about where we are in the plan and what the plan outline looks like and what different sectors we're covering in the risk assessment and resiliency plan. So with that, we're going to get started on agenda item 2. We'll start with a presentation from Dr. David Easterling from NOAA. Dr. Easterling is a climate scientist at NOAA. He's a Chapel Hill native. He has a PhD in geography from UNC, and he's the director of National Climate Assessment Technical Support Unit. This is one of the groups that's very active in the National Climate Assessment, and we are very fortunate to have Dr. Easterling's support in bringing the national analysis process and procedures into this work. And followed by Dr. Easterling will be Dr. Ken Kunkel. Dr. Kunkel is a research professor at North Carolina State University. He's the lead scientist for assessments at North Carolina Institute for Climate Studies. He has a BS in physics and a PhD in meteorology, and he's a graduate of University of Wisconsin-Madison. And so with that, I hope I covered everything, and if you don't mind introducing the team of people that are supporting you, we'll get started.
Thank you. It's good to be here. And as you heard, I am the federal lead for the National Climate Assessment Technical Support Unit at NOAA, National Centers for Environmental Information in Asheville. And Dr. Kunkel is our lead scientist, so we're both based up in Asheville. The Technical Support Unit provides support for the developing the U.S. National Climate Assessment, and So what we do is every 4 years, the National Climate Assessment, U.S. National Climate Assessment, is required to be produced and delivered to Congress. And the technical support unit up in Asheville actually provides all the support, provides scientific support. So we have a team of scientists that are led by Ken that provide the scenarios and projections that go into the report. We also do technical and scientific editing. And then we also have a team of web developers, and then people that actually, we have a team that collects metadata, okay, data about data. And basically what that is if you have a graph in a report like this, you have all the information that was used to develop that graph, what data set went into it, what methods were used to produce that graph, who produced it, what's the time frame and everything. Because we are required to do that kind of data collection and dissemination when we produce these reports. The technical support unit is actually, they're not federal employees. Almost everybody is actually an NCICS and an NC State University employee. We provide the funding from NOAA to then staff the group. So what we end up with is and we actually applied all the methodologies that we use for the U.S. National Climate Assessment in developing this report. So we have met all the standards, and I'll go through these standards in just a minute, to make sure that this is a robust, peer-reviewed, independent report. Okay, just a little bit of context. So the U.S. Global Change Research Program is the body within the federal government that is tasked with producing this report. It's comprised of these 13 agencies, and I'm not going to go through all of them, but it was actually formed under the U.S. Global Change Research Act that was passed under the first President Bush. Okay? And this law says that every 4 years there will be a U.S. National Climate Assessment produced that looks at the state of climate change in the United States and what the possible impacts are on a number of sectors such as agriculture, energy, water resources, and so forth. I'll be honest with you, the law was passed in 1990. I worked on the very first one, and we did not actually produce that until 2000. I think it was one of those things that the law got passed. Nobody really paid attention to it until suddenly one of the NGOs says, you guys are supposed to do this. And so we produced the first one, came out in 2000. The next one in 2009. The third one came out in 2014. And then the last one we actually produced 2 volumes, and I'll show you in a minute. We've gotten that time frame compressed down to 4 years. So we're now trying to keep this on a 4-year cycle to comply with the law. Okay, these are the covers from the 2 most recent. So we have volume 1 on the left. That's about a 500-page report that was put out in 2017 that looks at the state of climate science, both globally and in the U.S., and then down into the regions and even into the states. And then the second one that was actually put out in 2018 says, okay, we got climate change. What does that mean for the country? What does that mean for the various sectors such as human health, agriculture, energy, water resources, and so forth? And not only does it look at those sectors on a national basis, but it actually drills down into regions. And as a part of this effort, I want to mention one thing that we also produced when we put out the previous assessment was a set of what we call state climate summaries. So it was a request by the White House in about 2014 for each state to produce sort of a handout. And each one is somewhere around 6 to 8 pages. We have one from North Carolina. That's kind of where we started with this report. But each state now has a state climate summary that describes the climate, and then what we've seen in the past in terms of climate change, and then what we expect to see in the future. And we're currently in the process of updating those state climate summaries. This is just a brief slide that kind of shows you the requirements that we have to meet for these reports. And it's important because we are meeting these requirements for the North Carolina report as well. And the 2 things that are actually probably the most important are the Information Quality Act and the most recently passed Evidence Act. And these mandate that we have to document these reports very heavily to the point that we meet the standards for what's called a highly influential scientific assessment. This is a federal term for a report that has the potential to be used in a lot of decision and policy making, even by Congress. And we have met for this report all the requirements that we do for the U.S. National Climate Assessment. We've met that for the state report as well. And this is just my last slide, and I want to go through this because I think this is probably the most important one. It just shows you the steps and the processes that we actually have used in this report. Number one, we've drawn on a wide range of scientific and technical inputs. We actually formed, and Kim may talk about this a little bit, we formed a advisory committee for this report, comprised of mainly of professors at the various universities within the state. So we have people from East Carolina, Chapel Hill, NC State, Duke, North Carolina A&T, Appalachian State, UNC Asheville, and they all come. So we have about 12 people on this advisory team. Some of them actually served as authors. Others provided reviews. Secondly, operate on clear science communication principles. So we have tried to write this report so that it is somebody who has a little bit of a background in science, but are not a climate scientist, can read and understand. So we've tried to stay away from climatological jargon, if you will, as much as possible. So we talk about hurricanes rather than tropical cyclones, that sort of thing. This is very important. Ensure transparency of the process and the information. So how we produce the report. And I want to say one thing about the report. Schussman mentioned that we just started talking about it about a year ago. Typically, this kind of report would take on the order of 2 to 3 years at a minimum to produce. And we actually produce a very high quality product in the course of about maybe 6 to 8 months. We have employed an extensive review process. So we have the committee. Each person in the committee reviewed it and provided comments. And then we also had a set of anonymous peer reviewers from around the country go through the report. And this is about a 250 page report, to go through the report and provide us with comments. And we're currently plowing through those because we ended up with well over 500 comments. And every one of them in this process has to be adjudicated and a reasonable response provided to that comment. So if we accept what the recommendation is, we say we accept, we made this change. If we disagree with it, we say we disagree for these reasons. So we'll provide whatever scientific reason that we disagree with the recommendation. And those are going to be actually made public. We describe and document the process and rationale for how we reach conclusions. And Ken's going to go through a series of conclusions and how we actually decided on the language and how strong of the statement actually is. And that goes to this one right here. We actually have calibrated language in there so that if we say something is likely, that actually has a probability attached to it of 66 to 90%. Very likely is 90% and greater, and virtually certain is 99%. And Ken will probably talk about that as well. And lastly, identify areas with limited or emerging data and scientific uncertainty, because science is uncertain. Scientists deal in probabilities. We don't deal in absolutes. So everything has a little bit of an uncertainty with it. So anyway, these are the important points to keep in mind when Kim is going through the results. And I think that's all I've got, and I'll be glad we're going to take questions now or later. Okay, if anybody has any questions on the process, I'll be glad to answer them. If not, Ken's next. Okay.
Okay, so I'm going to provide a little bit of additional background, and then I'm going to plow through essentially the essential key points that will appear in this report. So Dave talked a little bit about who we are. I'll just say a couple more words about that, and the report itself. I will talk specifically about report findings, and regional highlights once I talk a little bit about the process. First of all, who we are. Dave said that we're in Asheville. We're a cooperative institute of NOAA. So we're co-located with Dave at the National Centers for Environmental Information. And as he said, most people in the technical support unit are part of the Cooperative Institute and are North Carolina State University employees. And NC State is the managing entity of this Cooperative Institute. So we have a team of scientists in this institute. The technical support unit itself includes core scientists, editorial staff, graphics producers, and and web developers. And so this is the team that's part of this institute that has been helping with producing this report. Okay, so Dave talked a little bit about this, but what's gone into developing this report? Well, probably at the very top of the list is the National Climate Assessment. We are, in this report, fully consistent with the 4th National Climate Assessment. Now, we're more detailed and more specific to North Carolina, but we're not contradicting anything that's in the National Climate Assessment. Dave said we've been producing these state climate summaries, and that was a starting point for the report, peer-reviewed science literature, and then the climate science expertise of the authors, the advisory panel, and then the input we've received from the reviewers has helped to clarify portions of the report. We've thought about some of the language based on the review comments, and we're still going through that process. And the report does address some of the specific needs that were identified early in the process from state departments and cabinet designees. Okay, Dave's talked about the Climate Science Advisory Panel. This is actually who's on this panel. I'd like to just say it's probably obvious, but one of the nice things about North Carolina is that we have really prestigious academic institutions in the state, and we, as part of those institutions, we really have top-notch climate scientists that we were able to engage in this report. And these people have national and international reputations. And what I was really pleased about, Sushma talked about us kind of stepping up because of this importance of this activity. Everybody we asked to be part of this said yes, basically. And there's a great desire to contribute in this panel of experts that we have. And about half of them are also authors on the report. We have one person here on this panel, Kathy Dello, who's the new North Carolina state climatologist here, so didn't want her to go unacknowledged here. Okay, the process. We really got started on the report. The lining up here is a little bit off, but got started on writing the report or developing the report kind of late June. We got initial members of the Climate Science Advisory Panel on board in June, and we started having conversations with them. The panel was fully formed in July, and we finalized an outline of the report at that time. We basically wrote the report from August through October, a very kind of a zero-order draft that was then reviewed by the Climate Science Advisory Panel. We finalized the full draft of the report then kind of in October, November. It was sent out in November, late November for review by anonymous external experts and by the Climate Science Advisory Panel. Since around the 1st of January, we've been working on revising the report. And so it's been a bit of a hectic time here the last 3 weeks. We've been really working hard to get this thing finalized. But as Dave said, we have hundreds of comments that we have to address. So we hope to finish this in a few weeks. I'll go back to that at the end here in terms of timing. Okay, so the report consists of 3 large components. One is a global overview of the state of the science. which I think is necessary to provide a framework for understanding what could happen in North Carolina. We discuss historical changes in North Carolina climate and then projections for the future. So I'd like to start out with also kind of a framework. There are some things about which climate scientists are essentially virtually certain about, and there's no question about it. And this does form the backdrop for this report. These are things that simply are not contestable from our standpoint. And these are what? CO2 concentrations are increasing rapidly. No question about that. The primary cause of that is the burning of fossil fuels. Carbon dioxide is not the only greenhouse gas, but it's the primary one. It is a greenhouse gas. It has a warming influence on the Earth. We know the Earth is warming, not just from our thermometer observations, but from many lines of evidence. No question about that. And then finally, and perhaps critically, the increasing concentrations of carbon dioxide and greenhouse gases are most likely causing much, if not all, of the warming. That's a really important point, and we throw this out as a non-contestable point. Some people might argue with it, but in terms of the climate scientists that have been working on this for many, many years, this is simply not a contestable point. And therefore, we begin the report, or part of the report has this statement in it, that exhaustive research has examined other potential causes of this warming, and the increase in greenhouse gas concentrations is the only plausible cause that is consistent with the observed data and the physics that governs the climate system. That's a really key sentence we have in the report, and it forms the basis for the rest of the report as far as I'm concerned. Okay, Dave talked about confidence and likelihood. And in the report, we use these terms. And what is the kind of the probabilistic definition of these terms? Well, that's given here. We say something is virtually certain in the report. We basically consider that to have at least a 99% probability of occurring in the future. Very likely, 90% or greater, so not quite as high of a likelihood. Likely, the next step down, is something that is at least 66% probable in our estimation. So kind of a 1/3, 2/3 odds. So it's not a coin toss, in other words. But there is more uncertainty about whether something like that will happen or not because of perhaps conflicting evidence. And I'll actually talk about a few examples of this and why some things we said very likely, other things we said likely, and it has to do with the kind of the weight of evidence. In some cases, we think maybe it is a coin toss about what might happen in the future. And we, in the report, have categorized these as low confidence about what will happen in the future. So these are the 4 basic terms that are used throughout the report and in the findings here that I'll show in just a minute. Okay, I'd like to just provide a little bit further global context for these findings. Regarding global temperature, this has increased about 1.8 degrees Fahrenheit since the late 1800s. And as I said in the previous slide, this increase is due largely to human activities, which have significantly increased greenhouse gas concentrations. Now, regarding the future, assuming that greenhouse gas concentrations continue to increase, it's virtually certain that warming will continue. So virtually certain, 99% or greater probability, assuming, again, on this condition that greenhouse gases will increase. Okay, what about projections? Projections now are derived largely from climate models. And so what I show here is a graphic from the 4th National Climate Assessment. And it shows increases in temperature from these climate models are projected out to the end of the 21st century, or out to 2100. We use two scenarios in this report. This is the same as we used in the Fourth National Climate Assessment. We use a high emission scenario, which is kind of a business as usual scenario. We'll continue to increase our consumption of fossil fuels as an energy source. This is the notation for this is RCP 8.5. Under that particular scenario, the models are showing about an additional 4 to 9 degrees warming by 2100. We also include a lower emission scenario, a lower scenario, which has emissions increasing until the middle of this century, and then kind of leveling off and gradually going downward. And under that scenario, the warming is considerably less, 2 to 4 degrees, most of which happens in the next 30 to 40 years. And after that, it stabilizes because greenhouse gas concentrations in the atmosphere are no longer increasing. So that's the two scenarios we're using here in the report. Okay, what about sea level on the global scale? Global sea level has increased by about 7 to 8 inches since 1900. And about half of this increase has occurred since 1993, which is shown here. There's two components to this that's shown here that are given in the report. This part of the sea level rise is due to melting of land-based ice, Greenland, Antarctica, mountain glaciers. So that accounts for, over this period, for most of the increase in sea level. But there's also an additional component here that's called steric sea level, which is due to expansion of seawater as it warms. So sea surface temperatures have been rising. As water warms, it expands. And so that's that component. So those are the two major components that apply to sea level. Okay, what about the future on the global scale? Whoops, went the wrong way. Okay, here we go. Again, a graph from the National Climate Assessment. And it shows number of scenarios for sea level rise, some very large, going out to 8 feet. So these are based on different scenarios for greenhouse gas emissions in the future and concentrations in the atmosphere and the amount of warming. But this particular low one is just an extrapolation of the current trend. This is, as a low end, is more realistic. So we're talking about changes from a little bit under 2 feet to more than 6 feet as potential on the global scale. Okay, what about this? What's the confidence in that? Well, it's virtually certain. It's at as high a level as temperature increases because it's just completely connected to temperature. And the two things that rising temperatures will do, one, ocean water will continue to expand as it warms up. And secondly, ice will continue to melt. And so it has the same level of certainty on the global level as temperature changes do. Okay, so what's the first key finding of the report? Well, it's this. Based on the global context that we live in and recognizing that regional changes can vary from global changes, nevertheless, our first key finding is that large changes in North Carolina's climate, probably much larger than at any time in the state's recorded history, are very likely by the end of the century under both the lower and higher scenarios. Doesn't say what pieces of the climate, but in general, we can expect large changes if we continue to increase greenhouse gas concentrations in the atmosphere. Okay, what about observations? What's been happening in the state? Well, this is mean annual temperature in the state through 2018. I'll get to that in a minute here. If you look at it, there's lots of year-to-year variability in state temperature. We had a warm period in the 30s and 40s, which is common to the U.S. as a whole, much cooler in the 60s and 70s. Since that time, it's been warming. The last 10 years here, as I state in the bullet, have been the warmest 10-year period in North Carolina. The previous warmest 10-year periods occurred back here, but this is about a half degree higher than what happened here for a 10-year average. And I say it right here. Now, we don't have 2019 in here because we completed the report in November. So 2019 wasn't finished. But what happened in 2019? Well, it was the warmest year on record. Kathy's office put out a news release very early in January about that very fact. And so we're not going to have that in our graphics, unless you want to delay the report a couple of months, which I think you don't want to. So, but we'll put a box in noting that we hit a new record this past year. It was also the second warmest year globally. Now, if you start looking at details, some interesting things emerge. When we look at seasonal, both annual and seasonal temperature, annual temperature has been rising in North Carolina. Each season has been warming in North Carolina. But some things have not been changing. And this is an example. Number of very hot days, greater than 95. Essentially no trend. The highest number occurred back in 30s and 40s, which were very droughty periods in the state. Lots of variability here lately, but no trend on the very hot days. But very warm nights have been going up here, and with some of the highest values we've seen in the historical record. Now, this is not the same, but similar to what's been happening both nationally and globally. Globally, if you look globally, and you look at parts of the U.S., there has been upward trend in both of these kinds of metrics, hot days and warm nights. But the increase in warm nights has been greater both globally and nationally if you look at other parts of the U.S. In the Southeast, however, we don't see a trend in hot days, and that will, as you will see in the next slide, affect our likelihood statement. So what do we expect for the future in temperature? Well, first of all, we do expect that it's very likely that North Carolina temperatures will increase substantially in all seasons. Now, just to point out here, that's a little bit lower level of confidence than we have for global temperature changes. So we said virtually certain that global temperature will change. Very likely that North Carolina temperature will change. The reason for the slightly lower confidence level is simply because if you look at observational data, global pattern or global trends apply most places, but we do see regional variations in trends across the globe. And the same thing is seen when we look at national level. So, there's some chance that they won't go up because they could vary regionally, but it's still very likely. Now, regarding the number of very warm nights, it's been going up. We have no reason to, from a scientific perspective, to think that that will change in the future, and it will probably go along with overall North Carolina temperatures. Now, what about hot days? And I didn't show cold days, but they also haven't been going down. These two things we have stated it's likely that hot days will increase in the future and cold days will decline in the future, but we have dropped that down from very likely to likely. And the reason is that we see these global changes in increases in hot days and decreases in cold nights, or cold days and nights. And it's likely that that trend will catch up with North Carolina. But we don't see it yet in the observational data, and so we have lowered a little bit the probability that that will occur. Okay, this shows maps. We have these kind of maps in the report. I just want to kind of orient you. This one's for very warm nights, and this is for hot days, very hot days. And we have chosen 3 particular combinations to show in the report. We've got to make some choices in the report about what we show. We're not going to give you 1,000 graphics. We just simply don't have the bandwidth to produce that. So what we've chosen to do is to take 2 future periods, 20-year periods. One is 2021 to 2040, so that's the upcoming 20 years, and then mid-century 20-year period, 2041 to 2060. We've chosen two scenarios, as we do have. We have the high scenario with the early period and with the middle period. For the low scenario, we only show the middle period changes. The reason we do that, save space in the graphic, but also there's not a lot of difference between the high scenario and the lower scenario in the next 20 years. They're both basically following kind of the same path, so it kind of shows the same thing. So just this gives you a sense for what the models are showing. Whoops. Okay. What the models are showing and kind of the magnitude of these changes. And I'm just going to show, I'm going to look at the mid-century higher scenario here in these two. For days with minimum temperatures above 75, what you'll see is changes of the order of a few, like less than 4 here in the western part of the state, to 10 to 20 in much of and even higher in the eastern 2/3 of the state, and kind of the same numbers we see for very hot days. So that's what the models are showing in terms of the magnitude of these changes. Okay, what about precipitation? When the historical record, this shows mean annual precipitation, statewide average here in the graphic. Lots of year-to-year variability, very typical of precipitation time series. No long-term trend. However, turned out that this past year, or 2018, I'm sorry, was the wettest year on record. And certainly Florence was a pretty big portion of that. But it was a wet year anyway. If Florence hadn't occurred, it still would have been an above-average year, and Florence really pushed it way above any other year. The latest year, 2019, I think is down around here. I think it's above average year, but certainly nothing record-breaking by any stretch of the imagination. What about heavy rain events? In the report, we show statistics for 3-inch days, the number of days that when you get a rainfall amount of 3 inches or more, and we see an upward trend in that in North Carolina. The most recent period that we show on the graphic in the report, I don't have it in this slide, had the largest number of such events for the state in the record going back to 1900. Okay, what about trends? Make 3 statements regarding precipitation trends. First statement is that it's likely that the annual total precipitation for North Carolina will increase. So why do we say that? Well, if you look at global patterns of precipitation change, there's very robust global scale patterns where the tropics get wetter, subtropical areas get drier, and mid-latitude and high-latitude areas get wetter. The models show that North Carolina is on the southern kind of boundary of this increase, this mid-latitude increase. So based on these findings, which have been pretty consistent from over time in terms of model generations, we have stated this likely statement here about total precipitation. Now, the other important comment, which I haven't made yet here, is that it's virtually certain globally that atmospheric water vapor content will increase. And that's simply because the oceans are warming up. The sea surface temperatures are rising. The maximum amount of water vapor in the atmosphere is a very strong function of temperature, rising about 3.5% per degree Fahrenheit. So as the oceans warm, the atmosphere gets moisture above them. And that happens all over. When the oceans warm in the summer, atmospheric water vapor content rises and they go down as the oceans cool. That will certainly happen in the future. It's virtually certain that the oceans will warm up. So it's virtually certain that atmospheric water vapor concentrations will increase. That's really important when we talk about heavy rain events, particularly large events, say like a Florence, for example, or a Matthew. Their source for water vapor is the ocean. And as these occur in the future, there'll be more atmospheric water vapor content. And models show this globally. Almost everywhere on the globe, extreme precipitation increases as the globe becomes warmer. And this is no different. We have no different expectations for North Carolina. And so our statement about extreme precipitation is that it's very likely that extreme precipitation and intensity, frequency and intensity in North Carolina will increase. Okay, sea level. We show in the report graphics about historical sea level rise in North Carolina at a few places along the coast. Sea level is rising about twice as fast along the northeastern coast of North Carolina than it is along the southeastern coast, and this is because of geologic processes, subsidence in the northeast part of the state. The statistics at two locations, 1.8 inches per decade at Duck, North Carolina, and a little less than an inch per decade at Wilmington, North Carolina. So those are the historical data that we show in the report. What about the future? Well, our statement is that it's virtually certain that sea level will continue to rise along the North Carolina coast, based on the combination of number of factors. One, of course, is global sea level rise, and then the addition of subsidence and geologic processes going along the coast. These are the ranges that are given in the report for these two locations, and this is by 2100, 1.7 to 3.9 feet at Duck and 1.2 to 3.3 feet at Wilmington. This really, in terms of the virtual certainty of this, it's really derived from global sea level rise and the virtual certainty that global sea level rise will occur. And, you know, the ocean rises everywhere pretty well. It's not quite as simple as that. There are some nuances, but we do expect that to happen in North Carolina. Now, one of the features along the coast is high tide flooding that occurs during high tides. That's projected to become nearly a daily occurrence by 2100 along the coast under the high emission scenario. If we look here at a graph we have in the report, this is for Wilmington. We have, in this graphic, we show sea level along the coast, and this shows the historical record, and this shows the range of projections that we have going out to 2100. This shows an analysis of high tide flooding along the coast. Historically, we've been getting more of these in the last 10 to 15 years. Here's the historical record. This shows what will happen under a high emission scenario and under a low emission scenario. So under this high emission scenario, by kind of 2080, we're getting it every day of the year virtually. And that's because the overall sea level has risen to the point where it's always above that current high tide flooding threshold. This is analysis that was provided by William Sweet of NOAA, who's an expert on this topic and has interacted with us on this report. Okay, hurricanes. What do we say about hurricanes? Well, historically, we have a graphic here that we produced for the report, which is, we call it the number of tropical events. These are hurricanes and tropical storms that either pass over the state or close enough to the state to have some impacts. If you look at the long-term trend, these are 5-year counts going back to 1850, very long record. First thing, if you just look at it, we don't have a trend in that time series. We had high values in the late 1800s, low values in the early 1900s. Since 1985, the numbers have been above average, but there's no long-term trend here. So hurricanes are obviously a topic of extreme interest to North Carolina, but also to the U.S. and for that matter, globally. And so there's a lot of work by hurricane experts that have gone on over the years. A group of hurricane experts produced a couple papers just in the last 6 months that were published. And so our findings here that I'll show in just a minute are derived from this very recent analysis by hurricane experts. And we actually had one of the people involved in these studies help us with the language in the report. So, a couple things about hurricanes. They're driven by water vapor. Water vapor is the fuel for hurricanes. And you need high amounts of water vapor in order to create hurricanes. They develop and intensify over warm ocean waters. None of this is, I'm sure, news to any of you, but I just want to provide the science basis for this. And that's because water vapor is high over the oceans. But other factors are necessary, particularly low wind shear, for hurricane formation and development. So as hurricane experts, run models, try to look at this theoretically and examine all the evidence, it's actually a very complex problem. And the projections that I'm going to show, it's very dependent on what aspects of hurricanes that we talk about. So we have different levels of confidence for different aspects. So the first thing is that the intensity of hurricanes, of the strongest hurricanes, is likely to increase. And why is this scientifically? Well, it's because, going back to basic physics of hurricanes, they run on water vapor. Water vapor content over the oceans will increase in the future if we continue to increase greenhouse gas concentrations. So when the conditions are favorable, and it will happen. It's not always favorable, but at some point you get perfect conditions for a strong hurricane. Those future instances will have more water vapor to work with. And so based on that, the hurricane experts have considered it likely that the intensity of those strongest hurricanes will increase. And that could result in stronger hurricanes affecting North Carolina. Now, there's high confidence in this for global changes. If you look globally at the statistics, but if you go drill down to any specific region, there could be other things that change that. So there's lower confidence for that statement at the scale of North Carolina. But nevertheless, is there a reason to exclude North Carolina from this possibility? And the answer, we think, is no. We don't have a reason why North Carolina could could dodge the bullet on these very strong hurricanes. Okay, two more things about hurricanes. The strongest statement that the hurricane experts are willing to make about hurricanes is that the heavy precipitation that accompanies hurricanes, like happened in Florence, is very likely, so they're very high confidence here, very likely to increase in the future. And that will increase freshwater flood potential in the state. And the reason is that it's virtually certain that water vapor content will increase. So when we get these, they're simply going to have more fuel to work with, and they'll produce heavier precipitation. Now, what about total number of hurricanes? Well, that's where we think it's a coin toss. We have low confidence concerning the direction of future changes in the total number of landfalling hurricanes in North Carolina. And it's because hurricanes require these other characteristics to be favorable, and we're unsure about how those will change. Okay, a few other comments about general storm types. We looked at a list of different storm types that affect the state. Okay, the first one, severe thunderstorms. These are storms that produce tornadoes and or hail. We do not think that the future changes in that is a coin toss. Research suggests that the conditions that are favorable for tornadoes or for severe thunderstorms that can produce these will increase in the future. We've labeled that as a likely outcome, that the severe thunderstorm frequency will increase. What about two aspects of snowstorms? There's two things we talk about in the report. One is total snowfall, and the second is the number of heavy snowstorms. So we can look at the overall spectrum of snow-producing systems, and then just the subset that produces the heaviest snow. We think our likelihood on these two things is essentially the same. And it's likely that both the total snowfall and the number of heavy snowstorms will decrease. And the reason is very simple: temperature. Temperature increases. Snow will not occur when it's too warm. So we think both of these will be affected by future increases in temperature. What about winter coastal storms, nor'easters, and ice storms in the state? We have low confidence concerning future changes in these particular phenomena. So we do not make a statement about whether ice storms and winter coastal storms will increase or decrease. What about floods, inland floods? Well, I shouldn't say that. Floods in general. Because of rising sea level and potential increasing intensity of hurricanes, we think it's virtually certain that there will be future increases in storm surge flooding in coastal areas of North Carolina. Inland, we have stated that it's likely that increases in extreme precipitation will lead to increases in inland flooding. If you remember from a previous slide, you may or may not, we said it was very likely that extreme precipitation will increase. We have a little bit lower confidence on the flooding part of it because that's a more complex phenomenon. It depends on conditions at the surface, soil moisture levels, for example, and how will those change in the future? Could those ameliorate some of the runoff and reduce potential flooding, for example? So we do think it warrants a likely statement that inland flooding will increase, but it's not as high as our statement on extreme precipitation. Droughts, another big issue for the state. We make no statement, or we have low confidence in whether the number or frequency of droughts will change in the future. However, droughts are a natural part of the climate. They will occur in the future. We think it's likely that when we do have a severe drought occurring, that they will be more intense. And it's really a very simple reason, and that is that we expect that future severe droughts will be warmer because of overall warming, and higher temperatures lead to more rapid evaporation of water from the soils, so that soils will dry out faster. So that for the same period of deficient precipitation, everything will dry out faster and those severe droughts will be more intense. As a result, we also think that it's likely that this will increase the frequency of climate conditions conducive to wildfires. The year 2016 provides kind of a nice case study for that. Fall of 2016, and now I'm sitting up here realizing I'm not quite sure if I got the statistics right. For North Carolina, it was either the driest fall and the second warmest fall, or it was the warmest fall and the second driest fall. So one of those two. One was first and one was second. Nevertheless, it was kind of, the perfect storm. Get the driest and the warmest at the same time. And as a result, this shows the U.S. Drought Monitor at the end of November, and it shows exceptional drought conditions in the western mountains extending over into Tennessee. And I think this was actually the very day, or it was one day, two, or before that, when the Gatlinburg fire erupted right across the border from North Carolina. Perfect conditions in the sense of, in terms of fuel. And then we got a windy storm that blew that completely out of control. Those kinds of situations, particularly the warmth, we expect will increase in the future and therefore lead to more frequent conditions that are conducive to wildfires. Okay, a few other things that we talk about in the report. One of those is the urban heat island. The state continues to grow. Our urban areas continue to grow. There doesn't seem to be any end in sight in that. And therefore, we expect that the urban heat island, which is essentially an outcome of a larger area of impervious surfaces where you don't have vegetation to essentially evaporatively cool the atmosphere, that the magnitude of the urban heat island in our urban centers will increase and will actually have stronger warming in urban centers. We also talk about air quality, in particular near surface ozone levels. And in this case, we are labeling this as a low confidence aspect of future changes. And the reason is that temperature increases favor increased ozone, but increased water vapor content tends to favor decreased ozone. And these two could counteract one another, and therefore we just simply have low confidence about what to say in this report about future changes. Okay, I think this is the final kind of climate point before I get into some other things here, and that's regarding infrastructure design values. So rainfall frequency design values, temperature design values for buildings, for heating and air conditioning systems. It's very likely, in the report we state, that some current climate design standards for North Carolina buildings and other infrastructure will change by the middle of this century. That is, that if one uses historically based design values, they will essentially be out of date. Now, there are efforts by professional societies to develop methods to incorporate climate change into design values, and my hope is that in the near future, we actually will have design values that can be used in the context of our non-stationary climate. Particular things that would be out of date if one used historical data would be precipitation design values, because we do expect extreme precipitation to increase, and dry and wet bulb temperatures. Dry bulb temperatures, both hot and cold on the cold side of the spectrum, because we expect both of those are likely to warm. And wet bulb temperature, very likely that will increase, but because of increases in atmospheric water vapor content. Okay, now let me delve into the report a little bit at the regional level. So what we did in the report, we have a section that talks about the state, but then because of requests we got and also advice from the advisory panel, that there's a desire to have a regional kind of packaging of the material. So what we did is we created a regional chapter, and we have looked at 3 regions of the state individually, and they're kind of standalone sections. So if you want to just look at a region that you're in, you can go to that section and essentially find the data for that particular region, but also the key findings that may apply to the whole state, but they're repeated in this section. So we have 3 regions: Western Mountains, Piedmont, and Coastal Plains. Let me very quickly go through a little bit of this. It's basically just, whoops. Where am I? Here we are. Okay. So, coastal plain. We have here a temperature record for the coastal plain. It's also showing essentially the same thing. as the statewide average increases with the highest values occurring in the last few years, you're going to see that the regional breakdown is very, very similar to the national or the statewide values. Very hot days and very warm nights. See this big increase in very warm nights in the coastal plain, but no change in very hot days. Extreme precipitation, a lot of variability in extreme precipitation metrics, but definitely here in the last 20 years or so, we've had lots of years with high values of extreme precipitation in the coastal plains. We also show metrics of drought here in the report, and thanks to Kathy Dello, who produced these graphics. And we had a period here in the 20s and 30s that had lots of years with that were very droughty. We've also had some recent episodes here in more recent times. Very warm nights in the Piedmont. Now we've jumped to the Piedmont here. That's been going up. We also show heating and cooling degree days for each region. Here's an example for the Piedmont, where heating degree days have been going down because of warmer conditions, while cooling degree days have been going up because of warmer summer day conditions. This shows a graphic. I'm showing projections here on the left, but I'm not going to get into those in detail. In terms of drought, the Piedmont actually has had fairly elevated episodes of frequent drought since kind of the late 20th century. Western mountains, as the case with all the regions, temperatures have been going up. Basically, all of the hottest years on record have occurred in the last 2 or 3 decades. Number of warm nights in the Western mountains, we don't hardly ever get up to 75, so we use 70 as our threshold in the mountains, and those have been going up with some of the highest values in the last 10 years. And number of hot days, unlike warm nights, have not been going up. Number of cold days has not been changing. Actually, there have been some episodes here, a very high number of cold days because of persistent patterns, the so-called polar vortex. Probably heard of that before. And here's some projections for these for the Western mountains. Mean annual temperature going up. This is the range of the different models. And days under freezing days going down, and also we do occasionally get 0 degree days, and those go essentially to 0 almost by the 2100. Okay, so now let me kind of summarize. We're continuing to respond to expert reviewer comments on the body of the report. We do hope to finish this next month. We will go through a final approval step by the Climate Science Advisory Panel. As Dave mentioned, this is a sizable report, 117 figures, many of which are multi-panels, and over 200 pages overall. And so this will be a lift for the advisory panel also to go through. Now, many of them are authors of the report, so they're very familiar with it, and they've already gone through it at least once. So, but it will take a little bit of time for that process to take place. Some final thoughts. If I had you captured in an elevator for, let's say, in a 25-story building, so I had a little bit of time to talk about it, what would I tell you about North Carolina's climate and the future? Well, I would say these are kind of the 5 biggest bullets I'd probably pull out. One, it's going to get warmer. Pretty well bet your money on that. Maybe even more, bet your money on disruptive sea level rise. This is a global phenomenon. You can't escape it if you live on the coast. Intensity or increases in intensity and frequency of extreme rainfall. That's a very good bet. I do worry about this more intense hurricanes. It's very likely to happen globally, and I see no reason why North Carolina won't share in the fun of this potentially down the line. They will happen. And then higher absolute humidity levels, which is nearly a sure bet. And the one thing that will affect, most obviously, would be summertime heat. Even if the temperatures, hot days do not increase, if you have higher humidity levels, you know what it's already high here in the summertime. Raise it further, and heat stress levels are going to be increasing in the future. So I'd like to, this is very much a team effort here. And I just want to acknowledge the people here. We have Sushma leading from DEQ. Here's the list of authors we have, and this really is a very distinguished set of authors. We have really, nationally and internationally known scientists on both the author list, and then many of these are also on the Climate Science Advisory Panel here. Really very fortunate to have a team with this much expertise and reputation. We have a number of other contributors who aren't authors but contributed to the report. We have this is our development team in Asheville that Dave and I essentially manage, and some of these are also authors, but very much working hard on this. Very nice thing here with this team is that they know how to do these things. They did it for the 3rd National Climate Assessment. They did it for the 4th National Climate Assessment. They did it for special reports along the way. I don't have to tell them what to do. They just basically know what to do. So that's a real advantage that we have here. And let's see, that may be the last slide I have. Yes, that's the last slide. So thank you for listening to me. Yeah. Well, first of all, I'd say that in the report we talk about the full range of greenhouse gases. So methane is obviously extremely important. Nitrous oxide, chlorofluorocarbons, these are all major contributors to the total greenhouse gas forcing in the atmosphere. Now, carbon dioxide is still the biggest, but when we look at the projections, and this is really the important part from the climate science perspective, that these scenarios have been that are at least plausible, have been developed based on the full range of greenhouse gas concentrations and projections for the future. So they're implicitly containing methane and possible projections for methane. So we're not ignoring it here. It's embedded in the projections. Now, in terms of what you're talking about, in terms of mitigation, reducing methane, or for example, all I can say is that that's sort of out of our purview is for doing the climate science, other than recognizing it's part of the whole greenhouse gas pie that needs to be considered in projections for the future. No, that's out of our kind of scope for this part of the report. Now, it might be that other parts of the resiliency plan will incorporate that information, but we're just dealing here with the climate science side of things in terms of what forces the climate system and plausible outcomes for the climate in the future. And we hope this information, frankly, would drive serious discussions about mitigation, but that's, like I say, beyond the scope of our report.
Do we have questions related to the climate variables that Dr. Kunkel addressed that you'd like some answers to?
Sir, I'm very concerned that I have seen nothing at all in your report, really, or I haven't heard any of your words about the effect of farming and food. It seems to me that with drought and severe weather, it will affect farming in particular, and so I'm wondering if your report addresses this at all.
There is another part of this plan that will address impacts, and the information that we provide on the climate should feed directly into assessments of the impacts on a variety of sectors in the state, including farming, which is obviously a big one. And a lot of these changes in climate would directly affect farmers. And I grew up on a farm, and I have great appreciation for the challenges that farmers face. So I do hope that these are fully addressed in the rest of the report.
Thank you. It's been very interesting. I was wondering if you looked at anything that might be like cause a step change in the weather here by 2100, like something like one El Nino after another, or real, we continue as business as usual, and we end up having methane released on a really vast scale from the permafrost. Things like that. I don't know that you're looking at predictive abilities in the last 10, 20 years more, and that's you're getting your likely and very likely categories. But scientists do talk about, good scientists do talk about something that would cause a real step change in the way our weather behaved.
Yeah, I think, I guess we would, scientists have talked a lot about these potential changes, and an example that would potentially affect North Carolina would be a slowdown or a shutdown of the so-called, I don't want to get too jargony here, but I will for just a second, thermal haline circulation in the Atlantic. But it's essentially for us, it's simply the Gulf Stream slowing down or whatever, and potentially affecting our weather here. I think that's these are all possibilities, but we would probably, if we talked about it in the report, we'd probably place low confidence in any statement about it, just because there's still a great deal of uncertainty about whether something like that could happen in at least, say, the next 50 to 70 years. And, if we went out thousands of years, we'd probably say, yeah, it almost surely will happen at some point. But the shorter time frame, it's very difficult for scientists to place odds on that. And I don't know if Dave has a different perspective on that, maybe, but yeah.
There's a lot of uncertainty on these thresholds, and you could suddenly get very rapid melting in the ice sheets over Antarctica or Greenland, but in the next 50 to 75 years, it's probably not likely to happen. But it will be sort of continuous melting, as has been shown by satellite measurements, that both those ice sheets are losing a lot of mass, and that water is going into the ocean.
Could you go back to slide 34? I had a couple of questions.
I don't have numbers. Oh, wait a minute. There's a
Down
number.
the bottom
Yeah,
right.
yeah. Okay, I see it. I was saying, how am I going to guess where 34 is? Yeah, here.
Okay, so this one is about sea level rise projections under the RCP 4.5, which is the low emission scenario in the future.
Yeah.
On some of the other climate stressors, you gave projections on the business as usual 8.5 scenario.
Mm-hmm.
Do you have business as usual projections for sea level rise for the 8.5?
Yeah, that's a good point. Trying to remember now whether we put those numbers in the chapter. I'll probably need to go back and.
Okay. Yeah. I think having a full understanding of what our future looks like under business as usual scenario is informative.
Yeah. Okay. Thank you.
And then a couple slides earlier on slide 29. If I can reconstruct my question here. So this goes, maybe there was one before and after. Could you go one before or maybe the one after? 30, yeah, that one. So these go out. I appreciate what you're saying. You can't put every scenario up there. Right? I mean, it's just, that makes sense. But again, I was sort of curious about directionally thinking about 2100. So the next couple decades, 20-year period, when I look at the high scenario, when I compare the high scenarios, so the top one and the bottom one, the next 20 years in the top in A, and then the subsequent 20 years in C, looks like things get a lot worse.
Yeah, if we did
another 20 years, or 40.
If we took the lower scenario, the 4.5, there isn't much difference going out to the end to 2100 compared to what we have here for the middle of the century. Mm-hmm. But for the higher scenario, I couldn't give you a number off the top of my head, but it's going to go up substantially by 2100 if we produce those same maps for 2100. Mm-hmm. We've done this for the National Climate Assessment. We do have maps that go out to 2100 for these very metrics, and one can see progression under the high emission scenario. It doesn't stop in terms of increases.
Right.
So, are you saying that you'd like to see these end of century?
I don't know if I'd like it, but I think it's important to look at because if just looking at C, it looks like in the Piedmont and coastal plain, I mean, your scale, I'd be curious how red it gets and if the scale changes, if you have more than 40. That was something I had a question about.
You can bet that if we went out the end of the century under 8.5, the scale no longer is adequate. We have to change the scale.
And then under which okay, so these are under the business as usual scenarios.
The top
and the bottom. In the middle is the lower emission. Okay.
Yeah.
Could you go to the prior slide? Okay, so this is the average annual temperature, and under the higher scenario is the range is the red.
Right, and that's the lower, that's the higher.
Okay. So I think this is where this was a part of my earlier question about the 8.5 or I guess the question is what is the temperature increase range under the 8.5 scenario? And it looks like that's what the red is.
Yes,
that's the actual temperature.
And I'm trying to remember the exact numbers, but I think that at 2100, I think this represents, now one has to be careful about the baseline here to make sure, but like 6 to 10 or 5 to 10 is the range for the higher business as usual, end of century temperature change for North Carolina. And for the lower here, 3 to 5 or 3 to 6. Those numbers are in.
They're in the report.
In the report. In fact, I think in the executive summary, once we get that done, which we're hoping to get done in the next day or so, I think we have those lower, higher, end of century, mid-century, and end of century. So we kind of have a matrix of 4 sets of ranges.
Thank you again for all your work on this.
Thank you.
Just a very quick question. In terms of the flooding in those projections, do you happen to have topo maps that align with the state that shows where flooding?
Where flooding?
Yeah.
I don't know what the rest of the report is doing. On the impacts and kind of resiliency part, but sure would be nice to have those. we haven't done that, and we're not really the experts on that anyway.
Gotcha.
So.
Hi, I just wanted to piggyback on something Jeremy was just raising about the temperature increases. I'm sure you've done this in the body of the report, but I think it's really important to emphasize that our current business as usual scenario is the higher scenario. That we're not, I think for the layperson coming in cold and reading this, it would seem much more logical that our current scenario is somewhere between. It's the median between the higher scenario and the lower scenario. And I think that it's really important in the report itself to emphasize what we're on track for right now is the high end of that high scenario.
Yeah. Okay.
Thank you, Dr. Kunkel and Dr. Easterling, for your leadership. And our sincere gratitude towards the time and that dedication you put towards this work. Thank you. So we are going to shift to the third part of the agenda, which has been talked about a little bit, and which is where are we on Section 9 of the Executive Order 80, titled The Development of the North Carolina Risk Assessment Resilience Plan. I am going to spend the next 8 to 10 minutes just speed through that plan development process and where we're at. I'm going to forward this. Okay. So, as many of you may be aware, Section 9 requires DEQ to lead a scientifically driven process to assess the current and projected impacts in North Carolina, which is what we retained Dr. Kunkel and his team to help us do. And it was designed more to help the state agencies understand what the climate variables are indicating. It has helped us, but the report is going to help us in developing our responses as we go into the future. Section 9 requires all cabinet agencies to assess climate change impacts into our programs, our services, and our operations, and that we integrate these changes into our mitigation and adaptation practices into our programs and operations. But most of all, it requires state agencies to provide leadership and support in carrying that understanding down to community and local levels that are most vulnerable and impacted to its stressors. And the plan is due March 1 of this year. This process has been a learning process for all of us, DEQ and all of our sister agencies. This is not something that we have been doing on a daily basis. So we, in the beginning, we're talked to so many people, and some of you have been involved in our other council meetings where this concept and this process has been presented. But an overview is going to be shown up right here. We decided to execute this requirement into 4 goal steps. The first one was to understand what the science is telling us. Part of what Dr. Kunkel did back in April April 8th, if I remember right, was a workshop we had with our council designees to identify what parameters and variables are most important to them. But subsequent to that, we had a council meeting, and there was a very detailed report on the National Climate Assessment and the Southeast chapter on what the leading trends are telling us. And based on that and our own understanding and our own research, the team was put together to address the impacts. In order to do the step 2, which is our goal 1, assessing the exposure to climate-related hazards, we brought another outside experts to help us as a team. Our folks from NOAA and NCICS and the Appalachian State University, the NEMAC folks, helped design this strategy, which is a systematic framework for looking at vulnerabilities and risks to our assets and our programs. So I won't get into the detail of this, but part of that included workshops with the designees. Many of them are here, and almost 60 to 80 people at some point has been involved in this process. We did 2 workshops to identify at a program level, perhaps even at a division level, what these very climate stressors are doing or not doing to the program and services that we offer. In particular, many agencies looked at the assets that we are directly in charge of, and perhaps even the assets that our services that we provide are in the path of the climate impacts. So all of this information, not only within the state agency's analysis, we also did workshops at the local level, regional workshops that was done throughout October and November. We did a total of about 2 in the coastal areas and then 5 in the mountain in the Piedmont area. And part of the reasons for doing these workshops was to understand what the local communities and the planners are seeing, and the issues that they are wanted to bring up to the state level. Many of the things we heard of, which wasn't surprising, but the level of detail and the economic impact and the stress that was put on the communities was something we all took away, related to the transportation sector, related to the energy sector, related to the commerce sector, and the environment and natural resources. It's just we have documented each of those workshop findings and how what we heard from those communities as a roadmap to our state agency writers to utilize as best as they can in their responses. The goal 3 is really where we are at, which is understanding these stressors and these vulnerabilities and risks. What do we do about it? How do we prioritize those risks into actions? And that's really where the rubber meets the road. We are in the process of first looking at preliminary view of what is in our authority, where resources exist, but also identifying long-term what the state needs to do. And part of that long-term analysis is deeper dives, and we talked a little bit about updating maps, developing additional metrics for engineering designs. There's a lot of work ahead of us, and that's one of the things we discovered as part of this March deadline, is this is a step towards building a framework and a pathway to statewide resilience planning. Ultimately, we would like to see the local governments and folks at the ground level to be able to take actions and to be able to understand how this culminates down to their communities. We see this plan as a one step towards an integrated statewide resilience strategy in between where we go between now to the next set of hazard mitigation plan that the state submits in the next 5-year cycle. And whether or not resiliency planning gets incorporated into that or outside of it is currently under discussions. And so my goal here today was to just give you a brief overview of what that plan is going to look like. As I mentioned, the Climate Resilience Toolkit has been applied, where we look at the hazards, we assess vulnerabilities and risks, and we investigate options. We anticipate all 3 steps to be fairly well completed by March, and the plan will address the sectors that are outlined here on the right. And I wanted to again acknowledge our partners from NKICS and the Climate Program Office within NOAA that's supporting North Carolina, as well as the UNC Asheville team. So our strategy for this is something new that was not discussed in previous council meeting, is that we're going to release by March the phase 1 plan, and that is understanding the climate stressors, assessing the impacts to our assets and programs, and qualitatively assessing the vulnerabilities and risks. We don't have the time and the resources to do deeper dives and do the data analysis and mapping and modeling and all those things that are needed at sector levels. That would be done, we're hoping, in the phase 2, where quantitative data-driven risk assessment could be done based on sector level analysis. We're hoping at this point that the phase 1 will just provide a framework for the path forward into a continuous roadmap towards statewide resilience planning. And by covering the sectors that we have addressed most of the areas that we have authority and a voice in. But ultimately, the integration of phase 1 and phase 2, where phase 2 is more the quantitative assessment, would be integrated into a framework that is an evolving process as the state moves forward. And currently, that is our hazard mitigation planning process that is used to submit to federal agencies for projects that would create more our ability to recover after a disaster, and integrating long-term resilience planning into those recovery plans. So the plan will consist of an introductory section, a roadmap, what I just described, the climate science report. The key findings will be presented here with an appendix of the detail of the entire report. There will be a chapter on climate justice, and then we will get into the risk assessment for each of the sectors that I mentioned earlier. Each sector will address the impacts, the vulnerabilities, the risks, and the preliminary actions for, I think we added up about 10 sectors. And then we will try to get the cross-cutting sectors into the discussions, but that may have to be as we go kind of thing. We would dedicate a chapter towards the long work that has been going on for about a year on nature-based solutions to look at ecosystem resiliency, carbon sequestration, and water quality benefits with 5 or 6 sectors that we are doing deeper dives on related to natural and working lands recommendations. So that section of the plan will highlight the stakeholder groups' key findings, and then more detailed report will be provided at a later council meeting. We'll also allow an entire chapter dedicated to be what our NCORE and our DPS and our team's vision is towards the path to climate resiliency. This is more of an outward plan or strategy that we will deliver to the governor as a possible pathway to integrate this planning and discussions into future work, as EO80 currently sets DEQ's role in delivering the plan. We decided to break this up into a series of documents. Eventually, it will need to be carried over by groups that have the authority and the responsibility towards this work. And so the contributing state agencies are listed here, and my apologies if I missed something. This was done pretty quickly. So that's the end. I'm going to give a few moments to have the council members ask any questions. I just want to have you guys take back that this is an important deliverable. We are working under a very tight timeline. You are getting phone calls on an everyday basis from our team, and please do your best to dedicate the time and the resources needed to address your chapters. I'm happy to answer any questions you may have. Tira, you have
I think this has been a wonderful effort in coordination as to how to deal with the problem. However, I'm wondering when it will be addressed preventive measures so that we can get down to the lower scenario. Because what I've seen, and maybe I've missed it and I'm not fully aware of everything going on, but it's more how to mitigate problems that will come, but not how to make it so it's not so bad. I'm being redundant, but
well, that's a good point, and I would say we have a lot of work ahead of us. We are looking into emission reductions and mitigation strategies, both in the transportation and the power sector. So, you know, that was not the scope of today's agenda, but we'd be happy to get you involved in some of that work going on. Part of moving forward is the Section 9 deliverable is one of the last direct deliverables under the Executive Order 80. And as you read what the purpose of the council is to obtain public feedback on what they should and could be doing. So you're welcome to provide the council suggestions for consideration.
Just to follow up, so on what Sushma said, which is important, is that this was about resilience, but other parts of the executive order do things to address mitigation. So one is setting a goal for the state, a 40% reduction in greenhouse gas emissions by 2025, having a greenhouse gas inventory. So now we have an accounting of, which Sushma and her team did and released about a year ago. So we know which sectors are contributing what percentage of our statewide greenhouse gas emissions. And then we're tackling the largest sector first, power sector, which is 35% of our emissions, through the Clean Energy Plan. And then we sort of gotten a start on transportation through directives in the EO80 on transportation, which is 32% of our emissions statewide through electrification. So transportation reductions require more than electrification, but that's the first step on that strategy. And then there are other sectors that we do need to tackle. So just wanted to, but that's sort of the approach on the mitigation side. Since September, a lot of the focus has shifted to resilience and developing this strategy while state agencies and stakeholders were still working on the mitigation side.
Thanks. So at this point, we're going to take a 10-minute break, 5 minutes break, and then we'll take public comments. Thank you.
We will I'll call the name of the person speaking and then the next person behind them to come to the microphone on this side of the auditorium. And you'll be able to see the timekeeper sitting directly in front of you, letting you know when your time is almost up. If we could start with Hua Huang, followed by Stephen Norris. And if everyone could take their seats. Thank you. Go ahead, sir.
Can people hear me?
Yes.
Okay.
Thank you.
Great. So, dear council, my name is Hua Huang from Raleigh, North Carolina. I am a member of the local Sierra Club Capital Group, and I'm here to share my thoughts on the EO80, which is a great initiative. In particular, I'm really looking forward to your electric vehicle plan, but I do believe that the plan can always strive to be better. I understand that DEQ is still in the early phase and trying to understand more about the impacts of climate change in North Carolina, and I think I speak for many other people in the room when I say there's a great concern for consequences of allowing for business as usual. One concern that's been repeatedly expressed by many people in North Carolina, particularly those in eastern North Carolina, such as Robertson County, is the apparent lack of response toward the construction of the Atlantic Coast Pipeline and the Mountain Valley Pipeline. Many impacted communities have stated time and again that the pipeline does not have a place in the plan for renewable infrastructure, let alone in their neighborhood. Methane is a much more potent heat-trapping gas than CO2, and I'm wondering if the pipeline is factored into the goal to reduce greenhouse gas by 40%. I also want to bring to your attention on the date, February 19th, 2020. That's when DEQ will decide whether to issue state water permit for Brown Valley Pipeline. The Sierra Club expressed concern for how the construction will be detrimental to water quality of waters and streams, as it will impact crossing 80 streams and tributaries and effectively damaging the stream habitats at home to many at-risk species, and the construction might lead to strengthening of the safety for drinking water of over 100,000 North Carolinians. The Sierra Club Dirty Fuel campaign is working with local groups to reach out to local officials to contact Governor Cooper to deny water quality certification to MVP. So this is why I'm now also respectfully encouraging that the DEQ take the concern for drinking water safety, stream habitat, on top of many other impacts that will be caused by the pipeline to do the same. The pipeline should not move forward in North Carolina, in my opinion, and the time and money we're spending right now should be spent into solar and wind. Thank you very much for the time.
Thank you. Stephen Norris, followed by Martha Giorlani.
Thank you very much for allowing us to give some of our ideas. Many of you here know, because we've all been listening to young people raise this issue, because of course their futures are completely dependent on whether we solve this problem or not, but that they are advocating that both at the local, state, and national level, that climate emergencies be declared. I have not heard anything like that from the state of North Carolina, from Governor Cooper, or from Department of Environmental Quality. Why that isn't the case, given the climate assessment, which Dr. Kunkel and the other fellow gave, I don't know. We clearly have an emergency on our hands. The state of North Carolina, as we know it, our lifestyles, our agriculture, our natural world, our animals, what we know now will not exist in 2100 if we continue on the path that we are going right now. There's another group that everybody here probably has heard about, the Extinction Rebellion. The Extinction Rebellion is a rebellion against extinction. We must take this climate emergency seriously. Now, DEQ, from what I can tell in EO80, has not addressed methane as what is pushing the greenhouse gas emissions up and causing climate change to become much, much, much more serious. Carbon dioxide emissions in this country are going down, thanks in part to what the governor has done and a lot of other people have done. But greenhouse gases are going up because of the increases in methane in the atmosphere. And if the governor allows that to continue through the construction of the Atlantic Coast Pipeline, through the methane that comes out of hog farms and so on, our civilization is lost. So please address this. Thank you.
Thank you. Martha Giorlani, followed by Alan Kroger.
Hello, thank you for your work on Executive Order 80, and I thought that the climate assessment was really fascinating. I wanted to talk a little bit about resiliency, and I think that it really must include a little bit, probably you've included it, but I'm not sure, having housing and services available for displaced persons and during our next climate disaster, and also housing for students as we develop curricula as needed for rapid solar, wind, and geothermal and energy expansion and other sustainable technologies in agriculture, forestry, energy efficiency projects. We need to be ready for what's going to happen to society as we change rapidly. To convert to a green economy, the Cooper administration needs to take on carbon polluting industries. All the gains to decarbonize state agencies are eclipsed by the enormous greenhouse gas pollution from Duke Energy's new gas infrastructure, the ACP, LNG plant, power plants, compressor stations, and from turning North Carolina forests into pellets by Enviva. These have all been permitted during the Cooper administration. Why boast about solar growth in North Carolina when Walmart, Target, shopping malls, etc., are not allowed to install rafts of solar panels? Duke Energy only allows a trivial amount of money for residential solar, considering the enormous demand. We are held hostage by Duke Energy, who is gouging their ratepayers by not allowing the cleanest and cheapest renewable energy growth. This has got to stop. We are morons to continue this energy monopoly. I've never heard this administration rail against this insanity. Governor Cooper needs to be loud in expressing his opposition to DE shoving gas energy down our throats, and he must give much more time to educating citizens on how DE is fueling the climate crisis. So why should North Carolina stop doing business as usual, embrace the green economy? Because climate crisis is dangerous and requires urgent, quick decarbonization. Because renewable energies are cheap and cheaper, and because natural gas infrastructure will become stranded assets. Because renewable energy programs will create thousands of new jobs, because we will inspire our youth and give us all hope. We must be able to tell our kids that North Carolina was not afraid to take control of the greedy, backwards, gas-loving Duke Energy and make them adopt renewables. That North Carolina was not worshiping money so much we failed to invest in a livable future for our young people. And that the North Carolina was not so stupid that North Carolina did only little timid things to pretend to fight the climate crisis.
Thank you. Since we are running late, I please ask that everyone be respectful of the time limits. Alan Kroger, followed by Tom Clark.
Thank you. My name is Alan Kroger, Director of Sustainability and Climate at Enviva. We would like to continue to welcome Governor Cooper's aggressive efforts to reduce carbon emissions and deploy clean energy. Today, Enviva is the world's largest producer of sustainable wood pellets. There are two ways that our North Carolina pellet production is helping fight climate change. One, our wood pellets are used as a renewable, low-carbon alternative to fossil fuels. Two, our markets for our product contribute to the strength of overall forest products market in the Southeast, which helps to ensure that private landowners in the Southeast can keep forests as forests in order to grow more trees and sequester more carbon. We were disappointed that the new North Carolina's Clean Energy Plan discouraged wood bioenergy, which is in conflict with climate leadership policies of Europe and the UN IPCC, which clearly states that sustainable wood bioenergy is a renewable source critical to our low-carbon future, and that sustainable forest management to provide timber, fiber, and bioenergy, and is critical to preventing forest conversion. North Carolina's forests are growing. It's clear from North Carolina's own data, measured by overall timber volumes per acre and in total. Even as Enviva's operations have expanded, inventory in our sourcing region has increased by 15%. Private forest owners grow 40% more wood than they remove every year. North Carolina's own GHG inventory estimates annual forest sequestration is up to 36 million tons, 25% of your state's gross emissions, and annual carbon sequestration is growing year on year. The CEP also questions the carbon neutrality of bioenergy, citing just one study to conclude that methodology should be challenged at the national and international levels. There are other reputable sources to review, like Wang at University of Illinois, DeVetti at University of Georgia, that conclude the exact opposite. Every year, only 2% of the Southeast forest is harvested, while the other 98% continues to grow and store carbon. Any emissions generated when bioenergy is used for energy are more than compensated for immediately by sequestration at the forest landscape level. The combined effect of forest growth and our displacement of fossil fuels means bioenergy is net carbon beneficial. EU law mandates that this will remain the case. Wood bioenergy is sustainable when it comes from regions when carbon stocks are stable or increasing, as it is in North Carolina. In closing, wood bioenergy is part of the solution to climate change. If it is sustainable and is backed by appropriate safeguards, we urge the Council to recognize that, after all, the state's working for simultaneously sustain jobs and economic activity across the state and reduce carbon emissions around the world. Happy to speak with anyone afterwards.
Tom Clark, followed by Kay Rybold.
Yes, ma'am. My name's Tom Clark. I'm from Cumberland County, North Carolina. I'd like to thank everyone for putting this on. But the Atlantic Coast Pipeline's annual emission of 68 million metric tons would amount to the equivalent of 20 coal-fired plants or 14 million additional cars on the road. This comes from an article in Oil Change International dated February 15, 2017, titled The Atlantic Coast Pipeline, Greenhouse Gas Emissions Briefing. Based on a News and Observer article, Governor Cooper's announcement means he's looking to cut roughly 23 million metric tons, so the ACP would shatter that commitment. The ACP goes through 3 states, so it's perhaps not totally fair to assign it all to North Carolina. But any way you slice it, the numbers don't look terrible. The numbers look terrible for Governor Cooper. Even just taking 1/3 of the ACP emissions, 23 million metric tons, since there are 3 states, would mean that the ACP adds almost exactly as many annual emissions as he's trying to cut. until Governor Cooper and our DEQ include the facts of the ACP's emission and stop drinking the Duke and Dominion Kool-Aid. His executive order, as I said once before, is nothing more than a joke.
Kay Rybold, followed by Marvin Winstead Jr.
Hi, my name is Kay Rebold, and I'm going to cut some of my statement because it's been said before, but I know most of you heard this, but we're here to remind everyone that the governor's clean energy plan does not take into account the devastating impact of the Atlantic Coast Pipeline. By approving the ACP, the governor is actually adding more greenhouse gas emissions to the amount the clean energy plan has in its proposal to cut, perhaps as high as 6 times more the amount of emissions than the plan proposes to cut would be generated by the ACP. Therefore, any benefit from the clean energy plan would be totally negated by the Atlantic Coast Pipeline. The governor's clean energy plan is completely undermined by this pipeline. It makes no sense whatsoever to have the ACP. We are urging DEQ to rescind the water quality permit and stop this dangerous and unnecessary pipeline. Thank you.
Marvin Winstead Jr., followed by Lynn Lyle.
Governor Cooper is to be commended for issuing Executive Order 80 to establish the North Carolina Climate Change Interagency Council. Plans that were submitted to Governor Cooper in late September of 2019 will no doubt achieve the goal of reducing greenhouse gases in North Carolina. But there is a huge flaw in the plans to reduce greenhouse gas emissions. Methane emissions are not addressed in the plans. When methane escapes into the atmosphere, it's 86 times more powerful than CO2 for the first 20 years of its escape. Methane will nullify the gains achieved by Executive Order 80. Methane issues must be addressed now, not later. The methane pollution from proposed frac gas Atlantic Coast Pipeline will be worse, as my friend Tom said, than 20 coal-fired electric generating plants or 14 million cars on the highways. Dr. Sarah Tabor of Cumberland County, North Carolina, spent 6 months researching the corporate claims about the proposed ACP. The title of her research paper sums up the unsubstantiated claims of the corporation succinctly: pipeline to nowhere. Her research study debunks corporate myths about the proposed ACP and the economic prosperity the companies say it will foster. The proposed ACP will hold Eastern North Carolina's economic development in shackles to an antiquated and dwindling technology. She outlines the assets of our region and explains how clean, non-polluting, renewable, and storage will meet Eastern North Carolina's energy needs now. Fracked natural gas is not needed as a bridge fuel. Renewables and storage can do it now, do it cheaper than fracked natural gas. The Sierra Club and NC Warren have both published plans that prove renewables and storage can do the job now. Thank you.
Lynn Lyle, followed by Gail Powell.
Hello, my name is Lynn Lyle, and I'm here from the Interfaith Creation Care Network of the Triangle. Actually, I added the word network. That's not in our title. We are a network, though, and we're less than 1 year old, and we are forming because there are a lot of people of faith who are informed by their faith, but also informed by science, who are very anxious about the future of our children, grandchildren, and future generations. And we are educating ourselves. At our first meeting this past February, we had 20 communities of faith represented by 40 people. At our meeting last night, we had 141 people at a local Methodist church here in Raleigh. And we are educating ourselves about what the state and local municipalities are doing about this, as well as keeping our eye on the national. And we hope to see much more of you. So we don't think North Carolina is doing enough, nor is any other state. I'm glad that you're doing what you are. Thank you very much. And I hope the governor will be able to step up the game. Thank you.
Gail Powell, followed by Keely Wood.
Thank you. I'm Gail Powell, a retired science teacher. Recently, both Italy and New Zealand announced national plans to introduce climate change education in their countries. And it would seem vital that North Carolina also develop appropriate climate change curriculum for our K-12 students. This would also require corresponding teacher training to ensure that teachers understand the content and the best ways to deliver the message. School counselors will also need to be trained to deal with eco-anxiety and the stresses that students may face from severe climate events. Is the North Carolina Department of Public Instruction participating in these efforts to plan for climate change? If not, they're missing an incredible opportunity to engage our students, help them cope with their fears, and offer inspiring ways to participate in solutions to climate change. Our current North Carolina science curriculum is woefully weak in content on climate change. Many current science teachers lack adequate knowledge to properly teach climate change as well. We owe our children an education that prepares them for climate change and engages them in hopeful, inspiring solutions to this challenge. I hope the governor's climate plan will address climate education. Thank you.
Keely Wood, followed by Crystal Cartier.
I'm Keely Wood. I'm a farmer in Lee County, and I question the Gas and Oil Commission. It's virtually certain. I learned that phrase today. I'm going to use it a lot. It's virtually certain, and I giggle when I see the hashtags and tweets with Governor Cooper's described as a climate change hero. He certainly doesn't deserve this title with supporting pipelines that aren't needed. And we certainly don't need the fracking that it supports. And so why I question the Gas and Oil Commission that's in place. So many things that have already been said. The other one is on the recent Environmental Integrity Project. They have an excellent website. They've done a national study on environmental issues for each state and how the DEQ's budget has been slashed by our government. North Carolina is one of the worst in funding, and that should be noted. The other thing is greenhouse inventory. I'm looking for an explanation of that more with the hog farming and the fracking and the wood pellets that are mostly all exported. The other thing is I hope they take this report and sit down Senator Tillis, who is a climate denier, as well as Senator Meadows, as well as send it to our president so he can understand a little bit more. Thank you very much.
And Crystal Cartier.
Hey, thank you. It's Crystal Cavalier. Meku Witahe, Muti Ashuti, Crystal Cavalier. I want to thank you guys for addressing the climate change in North Carolina. That's a big step. I represent the Native American Caucus, the Indigenous Peoples Movement, and I'm a water protector. My statement is I briefly looked over the Executive Order 80, and I found no mention of the connection of climate change as it is mostly adversely affects low-income, urban to rural communities, and predominantly communities of color, especially in Indigenous North Carolina. How will the Executive Order assess, study, and incorporate risk assessments of climate change to Indigenous communities and communities of our circumstances? Our Indigenous people existed long before technology and should have a seat at the table when it comes to climate change. And I wanted to give the opportunity to DEQ and the council to inquire if this has been previously addressed in any of the executive orders and invite our people to the table. Thank you.
Thank you, Ms. Cavalier. That concludes the public participation. We will post the slides from today's presentation on the website later this afternoon or first thing in the morning. So thank you all for joining us today.